Hi, so in this video we're going to do another type of factorising called difference of two squares. So let's look at the name of this. Difference just means it's another word for subtraction. Two means there's going to be two terms in each of these questions, and their squares means that they can both be easily square rooted. So two terms easily square rooted. And if you look ahead to all these questions, apart from one special one we're going to look at when we get there, all of these are a subtraction with two terms, and each of these numbers, with a little bit of work, some of them can be square rooted. Okay, so we're going to end up with two brackets. Factorising means putting into brackets, and one of them is going to be negative and one of them is going to be positive, and there's going to be two terms in each of them. All we need to do for this, if we can recognise this is difference of two squares, is what's the square root of 25? It's 5. What's the square root of x squared? It's x. What's the square root of 49? 7. So we get 5x minus 7. It's the first bracket already done. The second bracket is straightforward because it's just 5x plus 7. And that's all you need to do. Common question is, what if you happen to write 5x plus 7, 5x minus 7? They are both correct. Because it doesn't matter, because of the multiplication law, where it doesn't matter which order you're multiplying. If it's 5x minus 7, 5x plus 7, it's correct. If it's 5x plus 7, 5x minus 7, it's correct, as long as you've got your brackets in. Okay? So, two brackets. Square root of 9, square root of x squared, square root of 16. So that means it's 3x plus 4. That's it. Two brackets, square root of p squared, square root of q squared. So then it's p plus q. Now, these aren't straight away easily square rootable. But the thing with factorising is always check what we can do first. There's three types of factorising. This is the second type. The first time we learned about factorising, we did common factor, and you always should check to see if you need to do a common factor, and there is a common factor in these terms. So we can take out a common factor of 3, leaving x squared minus 9, and then difference of two squares within that bracket. Square root of x squared is x, square root of 9 is 3. Like that. Okay, so this is the one I was talking about. Doesn't look like we can do difference of two squares, but we can still factorise it. If we think about this, we're just taking the square root of each of these terms. What's the square root of 3? You could just write it as root 3 x minus 4 and root 3x plus 4. Because if you were to break that bracket out, root 3 times root 3 will give you 3. So it's just a different type of question, a different way of having a difference of two squares question. This last one doesn't look like it's squares, but at the side, if I did x squared times x squared, we get x to the power 4. So we can square root these. And so we're going to get x squared minus y squared, x squared plus y squared. And I don't need to stop there. Can't do anything else with this, but if I had given you that question on its own, you can see within it that that is also a difference of two squareds. So I could then further square root that, so it's going to be x minus y, x plus y, and then don't forget that one, x squared plus y squared. So that's how you factorise with difference of two squares.